Yeah, so I'm Ezra. I'm at CMU. And this is joint work I did with my lab mates, Buwan, Katie, advised by Graham Newbig and William Cohen. So this is kind of a departure from all of the previous talks in that we don't look at any code. It's aiming to help developers from a different perspective, which is answering questions about software. And I should mention thanks to funders, NSF, and Google. Quick outline here. I'm going to talk about Quasar-S, which is a data set built for doing software QA, and it's built from Stack Overflow. And then I'm going to talk about a new question answering task, which we're calling QA with context entities. Could be more creative name, but the idea is to take advantage of the fact that Stack Overflow has tags on questions and on posts, and we want to use those to improve question answering. Yes?
QA to some people means quality assurance.
Yeah, question answering, yeah. And then I'll talk about case, which is a model, a simple model that we've come up with to do question answering in this context. And please ask questions as we go along. So Quasar-S, this is a data set built off of Stack Overflow. So here's Stack Overflow. Spend a large portion of my life on here. And you can see that the topics are very domain specific. I can't interpret most of the words in these questions. And even an expert who could answer one of these questions probably couldn't answer another one. By contrast, easier QA settings, for example, would be when the questions are about entities and relations that are in some existing knowledge base. So for example, web questions, these questions are aligned to the knowledge base free base. So you might have the question, which college did Obama go to? And those are all entities within Freebase, and the relation is also a standard relation from the Freebase knowledge base. So that's an easier setting. Another example would be when the questions are about a limited set of relation types with answers found in well-structured text. So for example, Wiki Movies is a popular new question answering data set, and it answers questions about movies based on Wikipedia documents, but it only looks at question types in this set here, writer to movie, tag to movie. So for example, Ridley Scott directed which films? And the text here in Wikipedia is very well structured to contain the answer. Or which year was the movie Blade Runner released? You can imagine this pattern, Blade Runner is a 1982, et cetera, that pattern occurring frequently. So this is an easier QA setting. By comparison, if you look at QA in the software domain, there's no existing knowledge bases. KB means knowledge base. If you want to construct a knowledge base, it would be very expensive and it would be impossible to keep up to date. We have a large and unknown set of relations between different software entities. And you might not actually know the answer. There may be no document that contains the answer to a particular query. And the questions are only answerable by domain experts, even when they have access to the relevant documents to look up the answer. By contrast, like factoid or trivia question answering, anyone with access to a search engine could look up the answer. And then finally, generating training questions is hard because you need a domain expert usually to come up with the questions. So this data set, Quasar-S, is already released, and it's trying to get at this QA for software question from using Stack Overflow. It consists of 37,000 Cloze-style questions, so this is where you're filling in a blank. And they're constructed from the definitions of software entity tags. So let me show you what I mean. So a given question here, if you notice, it has tags that describe its topics. And those tags, there's actually a wiki on Stack Overflow that describes each one of those tags, defines it. So for example, here's the description of Django. And for a sentence, Django is an open source server-side web application framework written in Python. In Quasar-S, we'll have a question where we've removed Python. So the task is to fill in the blank, Python. And I should say that this sort of fill-in-the-blank question answering is viewed as like a first step in question answering tasks. Ultimately, we want to answer general questions. But this is viewed as a first step, and there's been some recent work showing that if you have a model that can do this, there's some hope that you can transfer that learning to general question answering. So the tagged posts and comments on Stack Overflow serve as the background corpus, where we want to answer the questions using that knowledge. So here's a post. This would be in our corpus of knowledge. It has tags also. This one's tagged with Django and some other stuff. And we create a document actually out of every sentence. And so here, so how to maximize performance in Python for this scenario. So this happens to be a document that is about Django and contains the word Python. So we might hope that there's a way to answer that previous question from documents like this. So our data set has 27 million sentences from the top 50 questions and answer threads, and 5,000 software entities that we're asking questions about. And it's available and online, so check it out. And it's a hard task even for humans. So experts in a closed book setting, so they don't have any access to the background corpus. They don't have any access to Stack Overflow. They do less than 50% accuracy on these questions. And non-experts, if they are allowed to search for the answer, do 50% accuracy. Some baselines that have been run include a search and read method, meaning you go and you look in the corpus. You have a module that goes and searches through the corpus for the answer, for a document that could contain the answer, and then you have a separate reading module that tries to extract the answer. And that doesn't perform well, and I can talk a little bit more about why not later. And finally, a simple RNN language model trained on the background corpus and then used to predict the answer on the questions does a little bit better, 34% accuracy. Questions about the data set? Cool. So now I'm going to talk about this new task which we're defining in order to take advantage of the fact that that this corpus is tagged. So QA with context entities. So for this task, we don't have any knowledge base available. But both the closed questions and the background posts are tagged. So this is kind of a form of semi-structured knowledge. And we want to use that structure to improve performance for answering these questions. So a closed question that we showed before, Django is an open source web application framework written in blank. It's tagged with the entity being defined, Django. And then a post excerpt, like the one I showed previously, has all the tags associated with that post. So let me relate this task to previous and existing QA tasks. So KBQA, this is where you're trying to model the probability of an answer given the question and knowledge base. reading comprehension, this is where you're actually trying to find the answer to a question in a given document, usually a pretty short document. And then search and read, which I talked about earlier, you have a corpus of documents, and you're trying to find the answer in that corpus. And it's typically done by searching and then reading. And that corpus might be all results returned by a search engine. So this new task that we're introducing, QA with context entities, the idea is that you've got a question and then you've got a context entity along with it. And you've got a corpus, and that context entity we're calling CQ here. Then you've got a corpus of context entity document pairs, where the CD are the context entities associated with a given document. So just to make this explicit, in the case of Stack Overflow, the context entity for the question CQ is Django. The question is the sentence, and the answer in this case is Python. Context entities for the document are the post tags, and the sentence from the post serves as one of our documents. So now I'll talk about a model. We developed a very simple model used to try to incorporate this tag information. So CASE stands for Context Adjusted Syntax Embeddings. And as I said, we want to incorporate both questions and context entities. So to simplify things, we use two models. A language model, which models the probability of the answer given the question, sentence, and then a context entity model, which models the probability of the answer given the context entities. And then we make sort of naive conditional independence, naive Bayes conditional independence assumption. Probability of the question and the context entities given the answer is the product of probability of the question given the answer and context entities given the answer. And if we do some rearranging, that ends up meaning that we can multiply our two models to get the probability, or in other words, in logit space, it would be additive. And then explicitly, how do we instantiate this model? For the language model, we use a BiGRU, which is the same as was run on the baseline. BiGRU means bidirectional GRU. And then for the context entity model, we do kind of the simplest thing possible. On the training corpus, the background corpus, we just compute how many, like the fraction of times that an answer co-occurs with a given context entity. And if C is a set of context entities, we average over them. Questions about that model? Okay. So the experiment we do, we compute the context model G as I described on the background corpus. Then we train the language model F, the BiGRU, on that background corpus with that context model present as a bias. Then since really we want to be able to answer the closed questions, we fine-tune on those questions by training a little bit further on that set of questions, but it's a much smaller data set. So as I said, this is a task hard for humans. The gated attention reader, which was the best search and read method, has trouble because it both has to read accurately and extract the answer from the document, as well as search accurately and return documents that can contain the answer. And those two things are kind of in opposition, because if you have better search recall, then the reader accuracy is going to go down. So getting that trade-off right is hard. And the gated attention reader is a reading comprehension model that is close to state of the art, I think, these days. So now if we look at just using the co-occurrence model, we can see it does surprisingly well, like 14% accuracy. Just saying, what's the answer to this question, given that this is the entity being defined. ByGRU alone, as we saw, did around 34%, and adding these co-occurrence counts gives you plus almost 8% accuracy, which is at this level a good increase. And then we can fine-tune both models, as I said, which is continue training them on the question set. And again, case gives a nice increase in accuracy. To demonstrate that both components of the model are important, here's some examples where each component individually fails, but together they come up with the right answer. So if our question is antivirus software is used to prevent, detect, and remove malware, and we want to fill in the word malware. If you look at what the ByGRU alone does, its first prediction is duplicates, because it's looking at sort of the syntax of the sentence. And when it sees prevent, detect, and remove, duplicates is a reasonable answer. And if you look at the co-occurrent counts model, the first thing it predicts is antivirus, because posts tagged with antivirus often contain antivirus. So neither of those models alone does well, but in combination, they provide the right answer. Similar with this next example, FPS is a measure of frame rate. When the ByGRU sees is a measure of, it says things like data transfer, execution time. But the co-occurrence counts model gives things that are sort of semantically related to FPS, like video. Frame rate is the second choice. So when you combine them, you end up getting the right answer. So it's pretty cool to me that we've got this split of responsibility between sort of syntax and semantics or topical information. And to demonstrate that further, we can look at we can sort of analyze the embeddings and look at the nearest neighbors in output space. When we look at the case model, we see that the nearest neighbors to iPod are other similar devices: iPod Touch, iPad, Apple TV. But if we look in output space for the ByGRU, it gives things that are semantically similar: iPad, iTunes, 3G, but they're not. They're not of the same type. If we look at the third example here, IntelliJ IDEA, that's an IDE, and Case gives 3 IDEs as the nearest neighbors. ByGRU gives 2 Java-related things, because IntelliJ is often used for Java, and then it gives an IDE, RubyMine. So by factoring out the context information in the co-occurrence counts model, the language model in Case is able to focus more on this sort of type or syntax information. And here's just a pretty picture showing the output space, output embeddings for the Case model. It really clusters things of the same type. These types have been derived from These types were derived from, I believe, DBpedia types that they gave to these software entities. And you can see things like, in pink here, image formats. Or in blue here, different types of testing, databases. So it's really clustering things here's design patterns. So it's really clustering things of the same type together, because sort of syntactically they occur in similar positions in sentences. So I want to mention some related work to this in language modeling. As we heard earlier today, RNNs have trouble incorporating long-range dependencies or context. And so there have been some approaches to this. You can take a context vector and append it or concatenate it with your input at every stage to the RNN. And that's what has been called early fusion. An example would be CL-LSTM, context LSTM. Or you can come up with a context vector and use that as a bias after your RNN has run, and use it as a bias for the output. And that's what we do. So you could call our model late fusion. But what we're doing is unique in that we're, there's a typo there, we're computing the bias based on the context entities. And so, and that really hasn't been done in language modeling. How are we doing on time? A few more minutes? Okay. So this is a bonus section, which is applying this model to other domains, because there's nothing really specific about software. Stack Exchange obviously has many sites, and they're all sort of deep expertise domains. And these are actually harder because they're smaller, there's less data. So we've created similar sites for Math Exchange, similar data sets for Math Exchange, Tech Exchange, and English Exchange. And these are soon to be released. Exactly the same format as Quasar-S. And we did the same experiments. And we found that we can significantly outperform the BiGRU or co-occurrence counts model alone, as well as several other simpler language models, n-gram language models. Finally, we looked at SPADES, which is a general QA data set. You wouldn't necessarily say that it has context entities per se. And we wanted to demonstrate that you can use this type of thing whenever you have entities annotated in a question. And there's a knowledge base on which SPADES is based, which makes it easier to answer SPADES. But it also lets us compare our method directly to how well we would do if we had a knowledge base. So SPADES is closed questions formed from natural language sentences, I believe from ClueWeb. And those sentences have been annotated with 2 or more free-base entities. So for example, Google acquired Nest, which was founded in Palo Alto, and the underlined words are linked to free-base entities. So the existing method for this uses the free-base knowledge base, but we just took the 90,000 training questions and used those as the only source of knowledge in this semi-structured way. So you have the question, which has nest removed. The goal is to fill in the word nest. And then as context entities, we take the other entities in the sentence, Google and Palo Alto. And the existing baselines from Das et al. Use a memory network using freebase, and they get 38.5% accuracy, or if they just use the training questions, they get 26.6% accuracy. And their major contribution was a way to combine both knowledge base and text, and they get close to 40% accuracy. We don't do as well because we're not using the knowledge base at all, but we want to approach that without using a knowledge base, and I think we've almost gotten there, around 36% accuracy. And then we also found that if you incorporate these co-occurrence counts into the state-of-the-art model, you improve on the state-of-the-art a little bit. So yeah, that's all. Thank you. Can I take questions? Cool. Yes?
So do you envision scenarios where you would need to look at several levels of context?
So by several levels, like what do you have in mind?
So maybe if you have, I guess, from programming languages point of view, I'm thinking about nested syntactic constructs. But maybe if you have, for example, if you do reading comprehensions or some type of task, whether it makes sense to find the context of the sort of section and then the paragraph and then the sentence.
Oh, yeah. Yeah, absolutely. That's not something we've looked at yet, but if you, that is something actually that using hierarchical models that has been proposed. But yeah, we haven't tried that, but it would be interesting.
I guess, is there a good data set for that, or how would you?
I don't know if there is one, but in the case of our model, I'm trying to think if there's a hierarchy to the tags. A case where you had a hierarchical tag structure, like maybe Wikipedia, where you have sections and subsections, could be really good for that type of thing.
Could you use this on Wikipedia?
You could, yeah. So you'd have to define what your tags are going to be. And maybe they're at different levels, like you said, categories, titles. Yeah, but absolutely. Yes.
Talking about language modeling in your task, right?
Yeah.
So the traditional way of comparing a language model would be reporting the PPL of your model. So have you come?
I'm sorry?
To report PPL, if you're going with a word and if
Oh.
you're going with character, it's a different method. So have you compared the simple group with the by group?
No, we haven't. What do you think it would do better?
Yeah.
Interesting. Why is that?
I don't know. I have a paper in language modeling which shows that by group doesn't perform that well on like PTP and text state benchmark.
Interesting. Cool. Yeah, that's definitely worth trying. Thank you. Oh, hey. Yeah.
Like every Q&A website, Stack Overflow is evolving over time.
Mhm.
There's the tags also, maybe, with the content.
Mhm.
Do you think about studying this axis?
Yeah, I think that's really important. I think that's why a traditional knowledge base would be really hard to construct. You can imagine running this, every month to answer questions with the latest info. When tags are new, you're going to have less information about them, so it's going to be hard. But it would be really interesting to see how this does on questions based on how popular or how old a topic is. Because you'd imagine, like on Java, it can do a lot better than on some new, yeah. Cool. Thanks.